Okay, so we're just going to start. I'm going to go through several different questions here with you guys. And throughout those questions, I'm going to give you some super important information on your calculator. So we're going to start with number one. And what I want you to do first of all is let's go to our calculator, and I'm just going to kind of give you some things that I want to make sure we're good on our calculator. Now, I prefer using Scratchpad. So Scratchpad is when you're on the calculator, you press this little button over here. It looks like a little calculator button. Okay, I prefer Scratchpad. Other people prefer documents. I know Ms. Vega preferred documents. I know in statistics, you need to use documents. So those of you who have had taken statistics or in it now, you use the documents. I prefer Scratchpad. You use whatever you prefer to use, but everything that I'm going to be doing is using the Scratchpad. I really like Scratchpad because it's easy to I'm going to show you how to clear your Scratchpad out. Instead of adding a new document or a new tab every time, I just clear out my Scratchpad. Again, that's my personal preference. So that's where I'm going to be working, but if you prefer to work with documents, you do you. Okay, so I work with Scratchpad. Now the toggle button on the Scratchpad goes back and forth. So right now I'm in the calculator feature. If I toggle again, I'm on the graph. There's a couple of things that I want to make sure you all are good here. First of all, you have to be in calculus class in radians. Those of you who are in physics, you in physics class need to be in degrees. So yes, you will have to toggle back and forth between radians and degrees if you are in physics. If you are in statistics, I don't think it matters because in statistics, I don't think you ever use trig functions. So if you use your calculator in statistics class and you're not in physics, you should be safe in radians. If you ever encounter a trig function, then talk to Ms. Kidder about that, but I don't think it's going to be an issue, okay? So to make sure you are in radians, this is unfortunate for those of you who are in physics. However, in physics, you use the calculator a lot, correct? In calculus, you don't use a calculator a lot. So those of you who are in physics, you're probably going to mostly stay in degrees. When you use a calculator in my class, just make sure you switch it to radians. We don't use a calculator very often. This is our first day that we're using one, right? So when you come to my class or you take a test or quiz in my class, make sure you are in radians, okay? And I'll try to remind you guys. To make sure your calculator's in radians, some versions of the TI Nspire, you'll see RAD at the top, and so you can tell. However, you might not, some don't have that feature. To make sure we all know how to do that, from Scratchpad in the calculator version, you're gonna go to Doc, Settings, Document Settings. I want everyone to go ahead and do this as well because I want to make sure that we have everything set up correctly here in our document settings. When I'm in the calculator, I like to put it on float. Float just means sig figs, and if you don't put a number after the float, then it will put however many sig figs the calculator can show. So I like in there to put it on float. Then your angle, I like to, or you're gonna have to put it on radians for this class. So if it's not already on radians, go ahead and make that default. Those of you in physics, when you go to physics class, you'll have to go back to degrees. Okay, everybody good with that? Now, we also will be using the graph a lot when you're using the calculator in this class. So let's toggle to the graph. Also, in the graph, you need to be in radians. Believe it or not, you can be in degrees in the calculator and radians in the graph. So we also need to make sure you're in radians. This is also unfortunate because to change it is different than it is in the calculator. Now, there's another important reason I want to show you this in the graph, because there's a really important thing I need to make sure your calculator settings are all set to for the graph. So please follow along what I'm about to do, even if your calculator is already in radians. So on the graph, I want everyone to go to Menu, not Doc, but Menu. So this is your graphing menu. You need to change your graph settings. So go Menu, Settings. You need to make sure your graphing angle is in radians. It does not matter the geometry angle. That can be in degrees, doesn't matter. But your graphing angle needs to be in radians. Here's a couple of important things that I would highly recommend. The first one, definitely you should do. You need to change your display digits to fix 3. Not float 3, but fix 3. The reason this is, fix means it will show, for sure, 3 decimal places. Float means sig figs, not decimal places. The AP test requires you, when you're using the calculator, to report up to 3 decimal places. Now, in stat, I believe it's 4. So if you're in stat, if you want to go ahead and say fix 4, then you might want to do that. AP calculus, you need to have at least 3. That means if you report 4, you're fine. You need at least 3. If you report 2, you are wrong. So to make sure you see at least 3 decimal places, you need to put this on fix 3 or fix 4. Please do that now. Okay, the next thing that I might recommend you do, this is personal preference, but you might want to check the box automatically hide plot labels. This is because you're going to be working a lot in the calculator, and what the plot label is if you graph several different graphs, in the graph they will like tell you the whole equation. Some of our equations get really complicated, and you don't want to mess up your graph screen and get it bogged down by labeling all those graphs. So this is just going to, if you click this button, it will help your graph screen be a lot clearer, because we're going to be working a lot and finding points. And this will just help make it not so clunky. So that would be my recommendation. So I would recommend definitely that here. All right, so now we're ready to start answering some questions. Again, I work with Scratchpad. What's nice about Scratchpad is, let's say I work a problem and I change my window and I've changed this whole graph. A really important tool with Scratchpad is docB. So if I was working the AP test, I would like Scratchpad because I could just clear it out, start a fresh new thing. Now on the AP stats, that's different because you're working with several windows. So I just press docB and it clears everything out for me back to the default. So just keep that in mind. Doc, then the letter B clears your Scratchpad. Okay, let's try a problem now. So there's more stuff that I want to show you with the calculator, but I'm going to show you in context of the problems we're going to work. Let's just start with number 1. Okay, we have particle motion. Particle moves along the x-axis. That just means it's going to go left and right its whole life according to this velocity function. That's a crazy looking function, okay? But that's the velocity function. Now, a lot of times on these, you're going to be given an interval. So I'm only on the interval from 0 to 3.5. A second particle moves along the x-axis. Now notice this time it gives you the position of the second particle for the same time frame. At what time t are the 2 particles moving with the same velocity? Now, to solve this is not that difficult. Hopefully you all understand what needs to happen, right? I just set their 2 velocities equal and solve, right? So the first function, we're given the velocity, but that's a really nasty equation. That's why this is a calculator problem. But do I set this equal to this? No. I've got to set the velocities equal to each other. So I need to find the second velocity function. Now that's a super easy function that we can go ahead and find the derivative of. So that's just 2t minus 1. So if I want to find when the 2 particles have the same velocity, all we're doing is solving this equation, right? Now that's easy in concept, but do you even know how to do that by hand? No, I would not know how to do that by hand. That's kind of impossible for us to solve by hand. That's why we have the calculator. Okay, so we're solving that. Please do not try to manipulate that equation. Don't try to multiply by the denominator. You're just going to use the calculator to solve. Okay, so our goal is to solve this equation. So we're going to use the calculator to solve. There are 2 ways to solve using your calculators. The first way to solve is to use the graph. And that is put the left side of the equation, put this side into F1 and this side into F2, and find their intersection, right? That's one way to solve an equation, yes? Okay, that's one way to solve. The other way to solve is to use what's called the solver in the calculator. It's called nsolve or numerical solve. Let's talk about nsolve. So nsolve is in the calculator portion. Okay, has anyone ever not used nsolve before? several of you have not used INSOLVE before. That's because it kind of comes with a warning. INSOLVE in the calculator. Do you think when we have things like this, we have a quadratic, we got a sine, do you think there's multiple answers that might make this true? Is that possible? Yeah, that's possible that there's multiple answers. However, INSOLVE, if you use INSOLVE, it's only going to give you one. Okay, so if the one is the right one, that's great. But if it's the wrong one, then you've got to know how to appropriately find the right one. Now, a couple of things help here. They gave me an interval to solve on, so between 0 and 3.5. So when I use INSOLVE and my answer is between 0 and 3.5, that's probably good. Okay, but there's other, so what I'm going to do is I'm going to show you how to use INSOLVE, but then I'm also going to show you another problem later in the problem set when it's not good to use or when you have to be really careful. So I'm going to show you how to use INSOLVE, but I want you to use it wisely. Okay, I want you to use it wisely. So let me show you how to do that. So in the calculator portion, not the graph, you're going to go to menu, and solving an equation is an algebra skill. So you're going to go to algebra, and then you're going to go to numerical solve. So it's going to say INSOLVE and then parentheses. So what you're going to do is you're going to type in this equation. So we're going to type in our equation. Now, I would highly recommend anytime you use the calculator to use the variable x. I know in the problem on the paper, you see the variable t, but I would recommend you always use x. So we're going to use 10 sine of 0.4x squared divided by x squared minus x plus 3. Then you want that to be equal to 2x minus 1. Now that's not enough. You can't just put in that equation. You've got to say what variable you're solving for. So after you write your equation, you're going to put comma x. Everybody good with that? Now, the reason I want to spend time also on the calculator is because we are human and we tend to make mistakes and typos. So please watch out for your typos. Yes, Sade?
How do you put the equal sign in there?
There's an equal sign button next to your trig button over here. And also the comma. Where's the comma? I'm typing it, so I don't know where the comma. Oh, there's the comma. Comma's below the pi button. Okay? Y'all good with that? So now press enter, and that value of x will make that equation true. Now that's all well and good because that's the answer, and is that between 0 and 3.5 as we were wanting? Yes. Okay, but you got to be careful. Sometimes they might ask for what are the first 2 times when this is true. It might have multiple answers from 0 to 3.5. So you've got to be careful with that. So if you need to look for multiple answers, or if INSOLVE doesn't give you an answer that you want, then I would suggest you use the graphing feature. And we'll do that later as well with a different problem. Any questions here?
Yeah, Ms. Herman.
Yes.
So I have 2. So do we use the derivative of the second equation because that's the velocity? And the
correct.
It's just like the position, I guess.
Yeah, so because it says at what time are the 2 particles moving with the same velocity? So since the second equation is a position function, we had to find the velocity function by taking the derivative.
Okay, and then also I did that answer with the graphing.
Yes.
It gave me like it just gave it to 3 decimal places. It didn't give that whole answer.
Yes, great. Let me just quickly do that. If you want to do this, you can, or you can just watch. I'll kind of show you what it looks like in the calculator, or sorry, in the graphing side. So if you did this in the graphing side, it would look like you put one side of your equation in F1, and we've done this before, but I'm just kind of showing you what this would look like. So in F1, you've got the one graph. And then in F2, you've got the other one, 2x minus 1, and you want to find their intersection. So if I find, and they only intersect the one time, but sometimes that does not happen. So you find the intersection. And since we did fix 3, notice that my decimals only go to 3 decimal places. In this calculator, if you want to fix it to 3, you can, but I wouldn't recommend it. But you would report 1.571. If you're rounding to 3 decimal places. The reason why I suggest you do fix 3 on the graph is so that, again, to not clunk up your screen. Does that make sense? If you have more than that, it's just going to be a lot more going on. But again, you have that X value of 1.571. Okay, any other questions? So there's 2 ways to solve that. One is better than the other in that if you had multiple solutions, the graph would be better.